In this video, I'll show you how to model direct variation equations. This is part 4 in the series. Question 1 reads, the horizontal distance s traveled by a projectile is directly proportional to the square of its initial velocity v. If the distance traveled is 1,250 meters when the initial velocity is 190 meters per second, find the distance s subscript 2 traveled when the initial velocity is 250 meters per second. To answer this question, we'll need to model it using y is equal to kx. So let's start with that. For question 1, we have y is equal to kx, where k is the constant. We're told that the independent variable here is our velocity, which is represented by the letter v. So let's replace x with v. We have kv. In addition, the horizontal distance, which is represented currently by y, should be in terms of s. So we have s is equal to kv. And another important thing is that it is proportional to the square of the initial velocity. So we need to square v2. The formula we'll be working with is s is equal to k times v to the power of 2. We're also given a point, and the point we've been given is 190 meters per second and 1,250 as our s coordinate. Substituting these values to solve for k, we end up with 1,250 k 190 to the power of 2. Therefore, k is equal to 1,250 over 190 to the power of 2. That will serve as our k value, and if you use your calculator, you'll end up with a very small number. So just keep it this way instead of evaluating it. The next step is to substitute this k back into the equation that we are building. So we have s is equal to 1,250 over 190 squared v to the power of 2. They want us to find the s coordinate when the second initial velocity is 250. So they tell us that v2 is equal to 250, find s2. All we have to do from here is substitute these values into this formula. Let's go ahead and do that. We have 1,250, this part hasn't changed, over 190 to the power of 2 times 250 squared. Next, we will evaluate this using our calculator. 1,250 divided by 190 squared, that's this part, times 250 to the power of 2, giving us 2,164. 2,164, and the unit is meters. So that is the distance traveled at this speed. In question 2, we're told that if y varies directly as the cube of x, so y is equal to kx, and we're cubing the x, y is equal to kx cubed, by what factor will y change if x is increased by 25%? To model this algebraically, we say that our new x, I1, is equal to our initial x times 1.25. And the way I derived 1.25 is that 25% as a decimal is 0.25. And since the initial x is being increased, we are keeping the initial x and adding 0.25 to it. That being said, this becomes 1.25, or in other words, the initial plus 0.25, where we model the initial as 1. I'm going to replace this into here, where I end up with y is equal to k times x1 to the power of 3. My x1 is 1.25x to the power of 3. Now I'll distribute this 3, this exponent, to both of these components, where I end up with, let's find out what 1.25 to the power of 3 is. It's approximately 1.95. So, k 1.95 x to the power of 3. Rearranging this, we get 1.95 k x to the power of 3. And if you look at the original model, this is equal to y. So that means that the original y will change by a factor of 1.95 the original. And we can even call this y prime. And so there you have it. 2 examples on how to model direct variation equations. Make sure to watch part 5 for more practice.